Here we have a two-dimensional system, so two equations and two unknowns. We're looking for the point in two-dimensional space that satisfies both of these equations. So I'm looking for an x value and a y value that's going to satisfy both of these relationships. And we're going to solve this with the substitution method first. So the substitution method says, in fact, let's first copy down the system. We have 2x plus y is equal to 5, but we also need minus 4x plus 6y to be equal to minus 2. So the substitution method says that you take one of your equations, doesn't matter which one, but you take one of them and you solve for one variable. Again, it doesn't matter which one. So let's take that first equation and solve for y. That first equation tells me that y is 5 minus 2x. So if I know that y is 5 minus 2x, I don't want to plug that back into the original equation because then I'm going to get something obvious. In fact, let's do that. 2x plus y is 5, and y is 5 minus 2x. 2x plus 5 minus 2x is equal to 5. Yeah, 5 is equal to 5. Who cares, right? So once you have information given to you by an equation, don't go back to that same equation, move on to the next one. So now that you know the first equation told you that y is 5 minus 2x, your second equation is where you're going to find new information. So let's replace this y with 5 minus 2x. Now I turned two equations with two unknowns into one equation with one unknown. We can solve this for x. Minus 4x plus 30 minus 12x is equal to minus 2. Minus 16x is equal to minus 32. X has to be 2. So now that we know what x is, we can figure out what y is. Y is going to be 5 minus 2 times 2. Oh, y has to be 1. So this two-dimensional system has a unique solution. The point that satisfies it is the x value of 2 and the y value of 1. In fact, if you were to graph both of these equations, these are both straight lines, then they would intersect at the common point 2, 1.